Lesson 7-3 is titled Two-Step Equations with Fractions and Decimals. So, as we learn this lesson, nothing is going to change about how we solve two-step equations. However, because we're working with fractions and decimals, there's a couple things that we want to remember. Alright, so just like in these examples here, any two-step equation, remember that first we want to get rid of the constant, that's the number without a variable, and then second we want to undo the operation to get rid of the coefficients, and that's the number that is attached to a variable. So in this first example, I would first subtract 53 from both sides, and then I would divide 2n by 2 to both sides, and I would get -3 for my answer. So nothing has changed with the two-step equation. All right, so this is the example that you're going to see in this lesson. Notice that there's a fraction within the equation. Now this is a one-step. All we have to do is get rid of the coefficient. 4/5 is attached to x by multiplication. We know that we can undo multiplication by dividing. Now here's the thing. When we divide a fraction by a fraction, remember from our previous chapters that dividing fractions, we can actually multiply the reciprocal. I'm going to abbreviate that here. So instead of dividing by 4/5, I can actually multiply by 5/4 to both sides. Doing this cancels out the fraction on that side. I'm left with just x. And on the right, I have 12/1 times 5/4. Well, now we're just multiplying a fraction like we know how to do. I'm going to look across and simplify. 12 and 4 both share a factor. I can divide each by 4 and I get 1 and 3. 3 times 5 is 15. So x equals 15. Let's do another example. So here's the rule again. Remember, when the coefficient of a variable is a fraction, meaning the number attached, you can use the reciprocal to solve the equation. So as soon as you see a fraction multiplied to a variable, you can just times both sides by the reciprocal of that fraction to get your answer. Let's do an example together. So here's a two-step equation. Remember, don't even worry about that coefficient until you first get rid of the constant. I'm going to add 6 to undo that -6 to both sides. I'm left with 2/3 n equals 28. 22 plus 6 is 28. Now my coefficient is a fraction. It's multiplied. So I'm technically going to divide by 2/3, and when I divide by 2/3, it's actually the same thing as multiplying by the reciprocal of the fraction. So reciprocals, I'm flipping the numerator and the denominator. Okay? So I'm going to clear this screen, and one more time, add 6, 2/3 n equals 28. When I see a fraction, I am going to multiply by the reciprocal. Multiply by the reciprocal. Put a whole number over 1. These fractions cancel out. I have just n. 28/1 times 3/2. Look across to see if you can do any simplifying. I'm going to divide both by 2. So 2 divided by 2 is 1. And 14. 14 times 3, because I multiply across, is 42. N equals 42. Remember, you can always check your answer by putting it back into the original problem. All right, let's just do one more. Let's do A. All right, remember, first step in a two-step equation, get rid of the constants. So I have -7/10 times k equals -21 minus 14. That's going to be a -35 because it's like adding the opposite, two negative numbers. All right, I see a coefficient that's a fraction, so I am going to multiply both sides by the reciprocal of this fraction. Keep the negative, because no matter where you put that negative, this fraction is negative. and just flip the numerator and the denominator. Negative 10 over 7. Fractions cancel. I have k equals, before I multiply, I'm going to look across to simplify. 35 and 7 can both be simplified down. If I divide them both by 7, I get 1 and negative 5. Negative 5 times negative 10 is positive 50. K equals 50. All right, one other method you might try when you see two fractions in an equation, because there's two, we can do something called the multiplicative property of equality that removes the fractions from the equation before we start solving. So I'm going to just rewrite this. 2/5 x plus 2 equals 3/4. If you want to solve it the way we did in the last step, you are more than welcome to. You would subtract 2 and multiply by the reciprocal of this fraction because it's connected to the x. However, I'm going to show you one more method. It's called using the least common multiple. If I want to get rid of this fraction and this fraction, look at the bottom numbers, the denominators. Find their least common multiple, or a multiple that they both go into. I'm going to use 20. I know that 5 and 4 both go into 20. If I multiply this entire side by 20, and what I do to one side I have to do to the other, I'm going to distribute the 20 to both parts. So 20 times 2 is 40, divided by 5 is 20x. 20 times 2 is 40. Then on this side, 20 times 3 is 60. 60 divided by 4 is 15. Now I have a two-step equation. I'm going to minus 40 from both sides. I'm left with 20x equals 15 minus 40, which is negative 25. I'm running out of room here. And then I'm going to, oops, I made a mistake. I'm sorry, I'm going to fix this right now. When I distributed, I made an error. 20 times 2 is 40. 40 divided by 5 is 8. I'm sorry, this should say 8x plus 40 equals 15, just like we had, so it was just this one error. I'm sorry about that. Now subtract 40, so I have 8x equals negative 25. Divide by 8, divide by 8. I get x equals negative 3 1/8. All right, sorry about that error. Let's do another example. So here's an equation. I notice there's two fractions. I want to get rid of both those fractions by multiplying both sides by a multiple of 12 and 6. Well, these numbers both go into 12. So I'm going to multiply both sides by 12. 12 times negative 7 divided by 12 is negative 7, because the 12s cancel out, plus 12 times y, so 12y, equals 1 times 12 equals 12, 6 times 1 is 6, 12 over 6 equals 2. Now get rid of the constants, add 7 because 7 was negative. I have 12y equals 9. Divide by 12. Simplify this fraction. That's not your final answer. I can divide them both by 3, 3/4. Y equals 3/4. So I'm just multiplying both sides by the multiple that the denominators have in common to eliminate the fraction. All right, the final example is doing a two-step equation with decimals. So I'm going to read this problem, we're going to write an equation and solve. Suppose your cell phone plan is $20 a month. You pay $20 a month plus 15 cents per minute. I'm going to use M for minute. Your bill 1 month is $37.25. How many minutes did you call on that bill? So every month you pay the $20 fee and 15 cents per minute. This particular month you paid this much money. We want to solve for M. So first, you are going to subtract the constant, which is the 20. So I have 0.15 M left, which equals $17.25 because I subtracted 20. Then I'm going to divide by the coefficient or the decimal. So I'm dividing by 0.15. When I do this, we could do it the longhand, 17.25 divided by 0.15. I'll also let you use your calculators. M equals 17.25 divided by 0.15. 115 minutes is your final answer. So you're not doing anything differently. This is a two-step equation. It's just that it involves decimals. I'm going to stop us right there. Here's your 7-3 lesson check. Sorry for the mistake I made earlier in the video. You have 4 problems to complete for class. Take your time and show all your work.